We use our hands to interact with objects, grab them, manipulate them, and release them. In virtual reality, however, such fine-grained interaction with virtual objects is generally not possible. The main constraint to successfully render haptics for virtual objects in a realistic way is that the controller must be able to produce and endure human-scale forces during interaction and persist in rendering feedback, especially when grasping and squeezing objects when the forces on the controller are the highest. We present the CapstanCrunch, a haptic controller that uses controlled brake technology to render haptic grasp at varying compliance levels, and that can sustain human-scale grasping forces up to 20 newtons. It does so by using capstan-based brake for variable pure resistive forces and a clutchable spring that is capable of outfitting the stored energy of a built-in spring. This duality, capstan brake plus clutched spring, creates a unique device that can go beyond the limitation of a binary brake or a spring and can simulate human scale forces. In a simulation of a push button, the user finger reaches the surface of the material represented by a brake and pushes it in against the resistance of a spring up until some point where the brake is being released and the user feels the operation of the click of the button until the button reaches full brake. Another example of interaction implemented with CapstanCrunch is an assembly of toy construction block. There are 3 stages to the assembly. First, the 2 blocks are brought together by bringing the fingers closer. In stage 2, a force is applied to connect the 2 blocks together. Once the blocks are connected, the brakes comes into full stop, and then the finger retreats. Final example of interaction implemented with CapstanCrunch allows user to cut materials with a pair of scissors. The gradual growth of the force due to the increase of the material lever length is approximated by a set of discrete steps. We presented CapstanCrunch, a haptic controller for rendering grasping feedback up to human scale forces. CapstanCrunch is built around a novel linear adjustable friction-based capstan brake that renders human scale forces without the use of large, high-force, electrically powered consumptive and expensive actuators.